Hello, everyone. Welcome to the data mining specialization, which is offered as a part of the Master's of Science in Data Science degree from University of Colorado Boulder. So this is the first course of the data mining specialization. So this is about data mining pipeline. So we're going to start with our first introduction. So what is data mining? Like, why do we care about this particular subject? So the learning objective for this course, we want to be able to identify different views of data mining and also be able to understand the key issues in data mining. So to get started, we have moved very quickly into the digital area where we are really surrounded with a lot of digital information. So think about our daily lives, okay? We are interacting, right, with various types of digital devices. We are creating a lot of digital content and also many different types of apps, and behind the thing, there's more data involved, right? So just think about the sheer number of users, right? We're talking about more than 4 billion users, internet users nowadays, and there are a wide variety of social media, smart devices that we interact on a daily basis. As another example, think about the scientific discovery, right? So in those domains, we are seeing increasingly a number of sensing devices and also increasing sensing capabilities, right? As a result, we are on a continuous basis, right, generating a lot of information for scientific discovery. Just as a quick example, so think about the Robin Observatory. So that is a telescope, right, that looks on the sky every night. It actually can generate more than 20 terabytes of information per night. And of course, there are many, many other application domains where you are seeing a lot of data being generated and used in many different ways. So we are quickly facing this like a huge amount of data, right? So think about the size of the data we have been dealing with. When I started like learning computer science, kilobytes was actually sufficient for most of the tasks. And then we moved to the areas of kind of megabytes, gigabytes. Nowadays, most of you probably have access to some kind of terabytes of hard drives. And we are already actually in the area where many of our application domains are dealing with the petabytes of data. And globally, the estimate is now on the order of tens of zettabytes. So we are dealing with a lot of data, right? So the enabling capabilities, of course, spans the creation of data. So we have the capability to collect a lot of data. And of course, we have the way to transmit them. So it's easy for us to share or access the different types of data. And we have the storage spaces, right? So we can now handle a lot of digital data. And it's the computation capabilities, right? Not only we have the way of getting all those data, but we have really the capability to manage and analyze all that data. But then one big issue we're dealing with these days is that we are drowning in data. That means we have a lot of data. We are really kind of trying to just handle that much data, right? But then the starving for knowledge part is particularly important and challenging, right? Because, well, our purpose of collecting all of this data and managing all of this data is not just that we have them, right? We really want to utilize them in a way such that they can help us. So that's really the key kind of motivation of being able to automate the analysis of such massive amounts of data. So that is what data mining is about, right? We're trying to learn a lot of information from data. Okay, so that's really generally refers to as knowledge discovery from data. Okay, so basically what it says that, okay, we have huge amounts of data and we're trying to find interesting patterns from our data. So what do you mean by interesting, right? Because you don't just like find anything and say, oh, I'm doing something great with my data mining tasks. Rather, you want to be able to find things that are interesting. So specifically when we say interesting patterns, we're talking about things that's new. So meaning that it's something that people don't know already, right? Because that's about finding new knowledge, okay? Of course, it has to be valid, so meaning that it has to be correct, right? And applies to some general scenarios. And this potentially useful part is important, right? Because you just not just find any random patterns, but the pattern, there should be a reasonably good way for you to say, oh, I can use it to do something. So that's the potential benefit of the pattern that you are finding. okay? And the last part is actually increasingly more important, okay? It's about ultimately understandable by human. Why is that important? Right? You could say, I may find a pattern, it is valid, it can be actually useful in some settings, but if it's just a black box and you don't exactly know what it's doing, it's probably not very useful, or you may not be very comfortable using it in like many real world scenarios. So rather, you do want to have some good understanding about why it works, how it works, and then you become more confident in terms of using it. Okay. The other piece is about the fact that we're typically learning useful knowledge from a lot of data, right? So the fact that we're dealing with huge amounts of data really calls for some very focused analysis and design to address the scalability and efficiency issues, okay? Because you may have data mining process that actually gives you very good results, but if it's really time consuming and may not scale well to larger amounts of data, that may or may not be the best choice. Okay, so many times we're talking about some kind of trade-offs, right? Is it more important that you have the best possible, most accurate model, or many real-world application scenarios may call something that is highly efficient? Okay, so you're always talking about how you can make your process more efficient, and many times you're talking about trade-offs between the effectiveness and efficiency. All right, as we're getting started, we'll say, okay, yeah, we know data mining is important and we're trying to learn, right, useful knowledge from data. But how do we get started, okay? So many times we would suggest looking at this like different views. So we kind of characterize this as this 4 different views. So that's really just a way to describe and like understand, right, your specific data mining task. So many times you can start with the kind of data you're trying to work with, right? Of course, the data mining, you got to have some data to work on. So starting with some generally good understanding of what kind of data you have, right? And what kind of semantic information it may have, how large it. So that's just starting with a good kind of view from your data side. The other one is about applications, right? Because many times you are doing this for particular application scenarios. So being able to understand what the usage scenario is, right? And like what the semantics and some domain knowledge, right? Those are actually very helpful for you to better define and also interpret the patterns you have found. And then so given the data, given the application, then generally you want to be a little bit more specific about what kind of knowledge you're trying to learn, right? You could say, well, find me anything that's interesting. Well, that's helpful, right? But it's really broad. So many times it's more specific, right? So are you trying to find some frequent patterns, or are you trying to find things that are just different from others? Are you trying to look for things that change over time? So those are all like more specific types of knowledge, okay? And we are like, as you kind of go deeper in terms of your data mining process, then you will have more specific like types of knowledge or patterns you're looking for, right? And of course, you need the techniques, right? So you say, okay, this is what I like to do with this kind of data for this kind of application, and I want to find those kind of knowledge, right? How do I do it? And that's really the technical aspect, and of course, a main focus of data mining. But all this need to come together for you then to be able to have a generally good idea in terms of what you're trying to accomplish, right, for a data mining task, right? So those arrows really kind of demonstrate how interconnected and also how important it is for you to have this kind of integrated view, because you don't just take one piece and then just focus on that one. You do need to have a reasonably good understanding of all those components and how they come together. So let's look at a little bit more specifics of the 4 different views. Okay, first one is the data view. Okay, traditionally people have like try to use those V's, and those actually just a really nice way for you to be able to characterize your data and understand what kind of data you're dealing with. Okay, so we started with the 3 V's. Okay, so the first V is about volume. Right, so you may have heard this term like big data all the time. So that's like many times, of course, we started by talking about just how big things are. Right, so you want to have a general good understanding about what kind of size. Are we talking about like millions of data points, billions of data points, or what? Right, so you want to have just kind of, and also how big are they? The next one is variety. Okay, so that just speaks to the fact that you are not dealing with a single type of data, right? You are usually looking at a mixture of different data types. Okay, so being able to understand their specific data types and how they work differently and how you may be able to integrate them is very important in many data mining tasks. The third V is about velocity. Okay, so that basically talks about changes or dynamics, right, of your data. So while they are kind of traditional, or even nowadays in many other scenarios, still dealing with static data. So that means you just get kind of one copy of your data set and you can work with it. But many other times you're talking about things that change, right? So you may have kind of like temporal samples, right, of things. And then, of course, you need to respond to it in certain ways. So the velocity really speaks to the point about how quickly data are being generated, but also related to that is about how quickly your analysis need to be done, how you react to the dynamic data. So these are the initial kind of 3 V's people are talking about. And then later on, we add another V. So this is the 4th V. Okay, so this V is about veracity. Okay, so what it talks about is really the quality of your data. Okay, so to what extent do you trust your data? To what point your data set is actually hopefully free of errors or any potential issues. Okay, and that actually has become increasingly important as we deal with more data and more different types of data in the real world scenarios. And all those V really is kind of like lead to the 5th V, right? That is about value, right? So that's really whatever you do with the data mining, we want to bring out value from the data. Okay, so many times really just think about what are you doing in terms of data mining, how useful or how could that be useful in some kind of real world setting. You may be finding kind of new knowledge for your scientific discovery, that's great. Or you could be kind of finding new patterns that you can leverage in the real world kind of application scenarios. There are also other ways to kind of describe your data. Okay, so traditionally, like the database community, right, has really kind of like led the advancement of kind of data mining in the early stages, right? So they were managing a lot of kind of relational or transactional data, right? Think about student records, right? You would have student information, their name, their student ID, you may have their email address, which major they're in, which year they're in, what courses they have taken, right? So that kind of naturally gives you a good description of students, okay? Or bank accounts, right? So you would have user information, right? You would have the customers, and also, of course, various transactions that may have happened, right, on within that those accounts, okay? Or if you go to a store, you're purchasing items, right? So naturally, the stores would have complete information of all the transactions that have happened, right? So they know which customers has purchased what items, and also maybe in what time frame, and also like in which store, right? So all that information can be easily aggregated, and it can be really useful for further analysis. Another types of data are generally referred to the kind of sequential or temporal or streaming. So as you can see, they have this kind of natural kind of sequence, right, associated with it, okay? So it's a bit of ordering, right? So you think about earlier, if you think about the store purchases, those are just saying, okay, you bought all those items together, right? So you're like, it's more about which items you purchased. But if you're looking at some kind of sequential information, they say, okay, you purchase some items in this particular transaction, sometime later you purchase something different. So that kind of temporal or sequential information can be particularly useful. Okay. Also think about the stock prices, right? So that of course changes over time, and you naturally would have a timestamp associated with the particular kind of like price points. And also like you could use, say, sensor readings. So those are scenarios if you are using sensors to capture information in your environment. Of course, you need to know when you capture this, right? So your readings are naturally associated with some timestamps. And this can be streamed data. So that means continuously monitoring some environment and sending you information. Another category generally refers to this factor, like if you consider your physical space, right? You have some kind of spatial notion in your data. Okay, so the sensor data, for example, right? We said that you may have timestamps, but if you know like this sensor is placed in this building, in this particular room, or in this particular area, then that's the kind of the spatial information you're trying to capture. Okay, and then if you're coupling the spatial and temporal, because you need to know where things are, but also how things are changing over time. So then you naturally get this kind of spatial temporal data. Okay, of course, like these are just kind of examples, but really kind of give you kind of like a general idea about how data can be very different, right? They come in very different forms, and depending on your application scenarios, right, you may care more about one aspect or the other or both. Okay, there are other types of data, right? So typically we say you may have seen kind of numerical information, you may have kind of seen some kind of like nominal information, but there are other types of more complex data types, right? So textual data is widely used nowadays and also actually a big part of many data mining tasks, right? So think about news articles, think about customer reviews, so those could actually be very useful in many scenarios, right? And also think about the multimedia data where you could have audio, video, images, and there are actually extensive research into how you can extract information and then learn useful patterns, right, from those kind of multimedia data. And web data on top of that, right? Because if you think about, if you go to the like World Wide Web, you would of course naturally have the text information. Many of them has audio, video, image information associated with that. But also another part is about the hypertext, right? So that's really the linkage, right? So you may like one web page may be pointing to the other one. So that's really the hypertext that actually is adding upon the other types of like content you may have. And building on top of that, right? So graph data or network data in general is actually a very powerful way of capturing relationships across different types of content, right? So you could have like in the social network scenario, this could be the physical space or in the online space, right? But you have a network information capturing like how users are related and how they're interacting with each other. Okay, also think about power grid, right? So that's in the physical space, you would actually know how the power grids, like the different connections happen, right, at a different kind of spatial scales. And also another one could be abstract, right? So this is the co-authorship. So think about usually when we publish kind of scientific papers, you have multiple authors, right? So every time you co-author a paper, that's kind of one information that is kind of linking two authors together. And if you kind of collect more and more papers, then you to see how some authors tend to collaborate more on certain topics, right? So the general idea is that data is really, of course, the one fundamental component of any data mining task, right? So you really need to start with a very good understanding of your data, right? What kind of data you are dealing with and how different types of data may be useful, okay? So just know that like in any particular data mining task, right, you may be focused on only a single type of data, but in many other scenarios, you will be leveraging multiple types, multiple data types in order to handle or for your particular task. So that's the data view, okay? So let's move on to the next one. So that's the application view. So as we said, right, many times when you're working on a data mining task, you usually have some kind of applications in mind, okay? And or of course you may say, I started with this application scenario, but it may be useful in other ones. But generally having an understanding of the intended usage scenario, right, could be very helpful in terms of defining your data mining task, but also making progress in that particular task. Okay, so think about one example, right? So this is more in terms more like the business intelligence angle. So there's a lot in terms of kind of market analysis, target advertisement. So these are the scenarios that you have customers, right? You have a lot of information regarding your customers and you're trying to figure out what kind of products, right, they may be of interest to certain customers, right? And then how you can, of course, make recommendations of certain items to certain customers, or just have your advertisement being, targeted to specific group of customers rather than general broadcast scenario. Another category, so these are generally related to healthcare or medical research, right? So in those scenarios, you're talking about patients or you're talking about just like people with certain types of disease, they may have certain like symptoms, or you're trying to, of course, diagnose certain disease, and then you may have a lot of kind of medical history information. You may have certain medical images, right? That also you can try to detect certain patterns, right? Drug discovery, similarly. So these are all the scenarios where you have a lot of information regarding different people. You have their kind of like medical conditions, but then you're also trying to look for like what treatments may be more effective. And a lot of that can be like data driven, and really can allow us to scale up to many different scenarios. The next category, so these are generally referred as science and engineering, right? So in those kind of domains, of course, like you could potentially also collect a lot of data regarding the specific like things you're trying to analyze, identify potential patterns, or try to model certain things, and that would allow you to come up with better designs or better kind of control mechanisms. Okay, so some examples I have actually worked on. One is about air pollution, right? So if you are trying to understand air pollution, so you would start with some kind of sensing capabilities, right? There can be stationary sensor data or mobile sensor data where you can basically measure the concentration of different types of air pollutants, and you can of course get this in a kind of spatial temporal scenario. And with that, of course, then you're trying to understand how things change over time and what factors may be related, right? To certain changes. Marine life, this is again a scenario you start with some sensing capabilities, right? So for example, you're trying to find the fish schools, right, within the water, okay? So you would have actually usually massive amounts of data, right, trying to kind of like tell you, right, as you're kind of like scanning through the ocean, right? So you can use some kind of like sonar. Acoustic sensing, so you can then check the signals you're getting and see whether you can, or infer whether you can find certain types of fish schools in certain areas and during certain time periods. And then over time, you can look at how things change. Okay. Electric vehicles, right? So this is generally related, of course. On one side, you will understand how people drive, because we drive differently. We drive our vehicles for different purposes under different conditions. So the weather can be different, the road condition can be different, traffic condition can be different, right? So that's like more like the context. But then you can also look at internally how the vehicle is performing, right? So particularly with electrical vehicles, you may look at the battery systems, right, and see how the battery systems are performing under different types of scenarios. Then that may allow you to come up with better design. Another types of kind of application scenario is generally focused on security, right? Because this, of course, you are just trying to ensure the security of a physical system or like softwares or something, right? So typically there are extensive kind of surveillance or kind of monitoring capabilities. So you are collecting a lot of data, right? But then with that, then you're trying to quickly identify things that may be suspicious, right? So this actually speaks a lot in terms of finding like anomalies or outliers in your data set, by knowing that you're dealing with huge amount of data and you really need to do that like very efficiently with kind of low latency. Also from the government, non-profit aspect, they're also dealing with many different types of data. And here you may use your kind of data mining capabilities for, say, better urban planning. Right? If you're trying to, say, build new road or add a new like a bus route, right? So of course that would help you if you know like the current demand and also how things may change. Okay, traffic control. So that's really related to kind of daily operations, but also kind of longer planning. Okay, and of course, in the education field, there's actually a lot of data mining as well, because you're basically trying to find like how effective, right, learning is happening and how things we may be able to come up with better strategies by understanding like how students are learning. All right, so these are really just kind of some kind of generic examples, right? But just keep in mind that data mining is happening almost everywhere, right? In any domain where you have some data or some capability of collecting data and maybe using that data, right? So there's potential for you to think about how data mining may be useful in those application scenarios. All right, so next, let's look at knowledge, right? So the knowledge review is kind of getting more specific about, okay, exactly what we're looking for, right? So you have some data sets you can work with, right? And you have some idea about the application scenarios, okay? Now you say, okay, what I'm trying to find, right? So there are, again, many like questions or many types of patterns you can try to learn, but here are just some of the major types. So one thing is that you're just looking for general patterns. So general means saying what things that happen frequently, right? So frequent pattern analysis is probably like a one core like task in many data mining project. Okay, and then you're looking for like potential associations, correlations, so that basically like relationships between certain kind of patterns or attributes. Okay, so as an example, if you look at like the different songs that your customers listen to, right? So you could say, okay, which songs are listened together, right? So usually in the same listening session, you can say those songs tend to be occurring together, right? And that actually would be very useful for you to then kind of like try to leverage that to make recommendations, right? Also, you can look for some kind of sequential patterns, right? Like users always listen to those songs in certain order, or particular movies, right? If it's some kind of series, then makes sense for people to follow certain sequences. So those are, again, frequent patterns, right? You're looking for things that occur regularly. The other one example, this is more about kind of the association or correlation. So that means is two events or two patterns more likely or less likely to happen, okay? So in this case, for example, if I know the customer has already purchased some item, right? And then you're trying to infer like, okay, given that the customer purchased this item, then what is the likelihood that my customer may also be interested in another item? So that's the kind of relationship you're trying to capture, right? And if you have that, then apparently you can also leverage that to make recommendations, right? Say, okay, well, yeah, if you like this, then you may also like that other thing. All right, the other one is categorization, okay? So this is just generally about kind of understanding the characteristics of certain groups, okay? So you're basically just trying to describe or identify similarities, right? How are certain groups of users or items or events similar in what ways, okay? So for example, like if you have all your kind of like customers purchase information, right? You know what they have purchased. Then you could say, okay, this group of like users tend to purchase those items together, or users who purchase those kind of items tend to have certain characteristics. Okay, and that of course would allow you to do more of this kind of like a targeted advertisement or some other kind of prediction scenarios. So once like when you categorize, you're looking for how things are similar, right? But also related to that is about you want to be able to say how things are different. So that's more like the differentiation, right? Because many times you're not dealing with just one group of customers or items of interest, right? You're actually trying to say, how are they different in certain ways, right? So here, like I may have, say, two patient groups, right? And then they somehow had like different, like a particular like treatment, right? May have different effectiveness. Okay, and then of course you're trying to say, okay, how are they different, right? Why it work for this group and not for the other group? Okay, so that of course could be very useful, right, in terms of further improvement. The other one is about, as we mentioned actually earlier, is about anomalies or outliers, right? So this just say things are different, right? And they are different from the general pattern, okay? And those could be significant, right? You could say, okay, there's just maybe errors in my data set, but of course it's important to identify those and fix them or remove them so that they don't kind of pollute your downstream analysis. Also, there are actually scenarios like those kind of outliers could be significant, right? Think about fraud activities, right? Of course, those are things that's just different and you really need to find them so that you can act upon them, right? And also in the scientific discovery domain, right, a lot of times we're looking for those extreme events, right? Then just, again, look different, right? But they could indicate some very kind of significant kind of like a phenomenon, and that is what people are looking for. When you're talking about kind of sequential temporal information, then there's another angle in terms of if you're trying to find changes over time, right? Because many times when you have temporal information, of course, they always don't change. That's one. But many times you're looking for things that change, general change over time, or anomalies within certain time periods, or like changes like of user interest. So those are all about changes over time. So when we talk about the data mining, there are like three important terms, okay? Especially when we talk about what kind of knowledge you're trying to gain, right? So the first part is generally more about a descriptive data mining, okay, or data analytics. So the idea here is that you're just trying to describe your data set, okay. So like that's about like the characterization, or like just say, okay, how things look like, right? That's more like descriptive. But then you're going kind of beyond that a little bit. You say, okay, given what I have seen in a more like historical pattern, now I'm going to make predictions about what would happen. Okay, that of course would be very useful, right, in many settings if you can predict how things will look like. Okay, but beyond that, there's also this about prescriptive. So the idea is not just say, if this is what I see historically, this is what I predict will happen. Rather, you say, okay, given my capability of understanding the historical patterns and what things would happen in certain scenarios, now I can actually prescribe, right, a certain strategy. So for example, like if you're trying to make certain new design, right? So the prescriptive part actually says that, well, I mean, you may have a few choices, but my analysis tells you that this is the better one, so you should try this one. So that's more like prescribing a particular solution, but based on your descriptive and predictive analysis. All right, so we talk about data, we talk about application, we talk about the knowledge view, right? So the fourth one, of course, is how do we make that happen, right? So that's the technical view. Okay, so you need specific data mining techniques to then support, right, finding particular types of knowledge from like specific data sets for a particular application scenario. So those are the terms we'll be probably talking about throughout the data mining course and the specialization, okay? But generally, we're talking about frequent pattern analysis, we're talking about classification, prediction, clustering, anomaly detection, trend, and evolution analysis. So let's briefly look at each of them. First one, frequent pattern analysis, right? As we said earlier, in terms of knowledge kind of view, right? We want to be able to identify what happens frequently, okay? So depending on what type of information you're looking at, right? So you may be looking at a frequent item set. So that's just like a set of items or events that tend to occur together, right? Think about your purchase records, right? You could say, my customers tend to purchase those items together, like milk, bread, eggs. These are probably ones that like they tend to occur frequently together, right? But that's just a set of items. And then if you're adding a bit more like a sequential information, right? So you can say if you have like a sequence of purchases, or in here, my figure shows the example of like a bird migration. So you may have the trajectory of the birds, right, migrating over years. You have the spatial temporal angle, right? So you can add in, okay, what sequence like tend to occur regularly, okay? And then you can look at like structure, right? So especially if you add some kind of graph information, then you're looking for graph similarities, right? Think about like in a social network, if you look at certain groups or communities, right? You may see frequent structure where it's kind of like star-shaped. So that means you have one leader who is kind of like interacting closely with the individual members. Or you may have some kind of peer-to-peer graphs where there's more like everybody's talking to everybody, right? So those are all kind of general structure that maybe occur regularly. But then beyond identify things that occur frequently, right, we also kind of like want to be able to identify relationships, right? So this generally is about association, correlation, which we'll spend more time talking about. But here, just kind of one example, right? So this is like one of our research. We're trying to look at like different types of kind of attributes that may be relevant in terms of air pollutant. Okay, so we'll look at like PM2.5, PM10, ozone, CO, SO2, and then other ones we'll look at like humidity, we'll look at the temperature, we'll look at like wind disposal speed and also the direction, right? And then we're just trying to look at how they're related, right? So the correlation kind of like basically kind of allows us to quickly identify things that are correlated, okay? And the colors, of course, indicate different levels of correlation, and they can be positive or negative. So those, of course, we'll cover in more details, but as we can see, this already kind of gives you a general overview of what's frequent, right, and how they're related. And then going forward, right, not only we want to be able to find frequent patterns, but also want to be able to differentiate, right? So this is generally what we're trying to do in terms of, say, classification. So in those cases, you would have the predefined classes, right? So here I have different images, and the images represent, say, dogs, automobile, plane, cat, right? So those are the different categories or classes. Okay, and of course you're usually provided with some training data, right? So like my examples here could be the training data, right? If you're looking for pictures of dogs, right, I have some examples, and the pictures of cars I also have examples. So those are the training data, and you can use the training data to build your classification model, right? And once you have that model, then now giving a new image, right, then you can then quickly determine which class it belongs to. Okay, so that's classification. Related to that, you like if you're trying to determine not kind of a few classes, rather you're trying to determine a numerical value, right? So this is generally referred to as a prediction, right? Numerical prediction in a kind of continuous range, right? So think about weather prediction, right? It could be predicting the temperature, wind speed, or amount of precipitation, right? So those are numerical values you're trying to predict, okay? Also stock price, traffic volume, right? All those are things you could be like that's like related to being able to differentiate things, but also then make prediction about what the value would be, right? Another thing related to classification prediction, which is also very useful in many data mining scenarios, is clustering. Okay, so as the name suggests, we're trying to find clusters. Okay, but the key difference between clustering and classification is that here we don't have any predefined class labels, right? I don't know how many classes I have, or I don't know like what each class look like. Rather is that I'm just giving the raw data points, okay? And I want to, of course, like find kind of like some kind of distribution. So the idea is that if you look at this like 2D space, right? If it's like all the data points are uniform distributed, then you don't see any clusterings, right? There's no clusters. But many real-world data sets, they do have those clustering effect. So that basically means that you tend to see denser areas where there are more data points, and there are areas that are more kind of sparse and the things are more separated. Okay, so in my example here, you can see the green cluster, I have the blue one, and also the red clusters, right? You can see usually like within cluster, like within each cluster, you tend to see denser, like more similar objects, right? And of course, between clusters, then you would have like a higher dissimilarity, or they are further apart. Okay, so that's the general idea with clustering, is that we're going to find like intra-cluster similarity, so high similarity within clusters, and more different objects across clusters. Another one, so in terms of the technique, is about being able to find anomalies and outliers, right? So we said earlier how an anomaly or outlier could be errors, could be extreme events, but you just need to somehow find it, right? How do you define it? So the general idea with anomalies or outlier is that they're just different, right? But that notion, of course, is very vague, and that's why it's actually challenging in many real-world scenarios to identify those. Okay, so here my example is, as you can see, like this is a temporal kind of like a data set, right? So you see this kind of like nice kind of seasonal or annual patterns, right? But then you can already see actually some significant changes, right? So there are things that are just like there are peaks that are just different of each other, and you see this pretty significant like level shifting, right, between the left half and the later part. Okay, of course, this actually also shows you actually how visualization could be very helpful, right? But of course, in many data mining scenarios, you are dealing with huge amounts of data, so manually going through all that would not be possible. So we're really looking for things that can automatically define the differences and also the norm cases, so that we can effectively find anomalies. Okay, so one more thing. So this relates to trend and evolution analysis, right? So this is the case that, as I said, usually when you look at your data set, they are dynamic, they change over time, right? So you need a way to understand how things change over time. So you could, again, you can use some kind of visualization capabilities, or you can use kind of like quantifiable calculations. But the idea is that by looking at the time series of data, you're trying to look for, say, general trend. So that means the general trend could be like a generally upward trend, even though there could be fluctuations, or downward, or some kind of like seasonal patterns, right? Those are general patterns, right? But of course, you would still be kind of looking for some kind of anomalies. And many times when you look at time series, it may be kind of like a composition of the various patterns. So it's not just one single pattern, okay? So here, there are, of course, many ways to look at the trends. So Google Trends is actually a very nice tools. If you go to Google Trends website and you can type in any particular keywords, right? So this is based on the search queries. So you want to just see what's happening or how things are happening over time. Just try to play with it and type in some keywords that you're interested in seeing, and then you can actually look at how it's changing over time. And some of them may have a bit of a quick increase, or think about things that may be kind of fluctuating every year or every 4 years, right? Depending on what that is. So that also actually give you very useful insights, and then you can act accordingly, based on what trend you're seeing. All right, so just to summarize, right? So here we're really just getting started in terms of talking about the data mining. Okay, so we say how data mining is really focused on finding interesting patterns from a huge amount of data. But to get started, right, always think about what kind of data you're dealing with, what kind of application scenarios you would like to use this for, and also specifically, what kind of knowledge you're trying to learn from your data. And of course, how are you going to do it, right, with specific data mining tasks. Okay, so that is all for today. Thank you all.